guys to put in there, okay? And that's all part of the reinforcing schedule. I bring surveyors into it because sometimes you're the only guys on site that can get back to the office and report whether a job has been done according to the plans. If the site's 2.5 hours away, you don't always have that privilege. Maybe one day with drones and things, we'll be able to fly them all over the place, but yeah, the person on site is the important one. So engineers, when you arrive in the office and you're giving your boss the coffee on your very first day, that's usually the first job, and you've done that right, then he will trust you probably to go on site and count the bars. And don't go, oh, is that my job for the day? Because it's probably the most important thing you're going to do is count the bars. So therefore, I do put a lot of emphasis on you getting it right. So just remember that when you're doing your calculations. The easiest way to do this section of work is to work in groups. 2 or 3 of you go home, have a go at it. Doesn't matter if you stuff it up, bring it in, have a good argument about it, and you'll probably find in a group of say 4, 3 of you have got one answer and one person's maybe stuffed up that question. The person who stuffed up will learn from it, and so will the others that maybe have got other bits wrong. That is the way to do this. It is very tempting just to ask the best person in the class to copy theirs. Yes, you'll still get some good marks, but you won't do my test. You'll just be over the top when it comes to doing that. So it is well worth it putting the effort in a group situation. Unfortunately, some of these examples have all gone now. 3 years ago, we had the motorway coming out of the tunnel with the great big ramps going over the top. We had this situation here holding them up. This is, I think, a photo taken directly from it. And what this is this piece here is your formwork. They would pour the concrete, and it's shaped in such a way that the crane would lift it up, then they'd do the next pour, lift it up, and then at a certain point they would join on to that reinforcing with the next bit of reinforcing with an overlap. And I used to encourage students to take a walk around there and have a look at it, because you could see it all going on. But if you ever get an opportunity, they do field trips, and the last one was to the Sky City where they're doing a lot of work, and most feedback from students was it was a very valuable trip. They learned a lot just from looking at what was going on. So you know, when I'm doing drawings, right? I've sat in an office most of my life doing drawings, but you can't beat being on site to see what actually really happens. These members here that bind the vertical bars, we call them stirrups or ties, and they're usually from bars that are smooth, so they're not deformed. They don't have those ribs on them, because their main purpose is to hold the other bars vertically together. So they are normally smooth or non-deformed bars, and they're normally in a situation where they're holding other bars together. If you don't know by now, I don't ever stop banging on about the Clyde Dam, because that was my biggest site experience. The Clyde Dam was what we call a gravity concrete dam, and or a mass concrete dam, and pretty much there's not a lot of reinforcing actually between in that the shape of the dam, but there are around these things they call galleys, which are holes through the dam, and they use them to do what we call dam deformation surveys. So the surveyors in there are using very complicated machinery, and they're measuring in millimetres how much the dam is moving. And that was all set up inside the dam when we were doing it at the time. Another example would be a gravity wall. Here's a picture of a gravity wall here. So basically the wall is being held or clicked together just without reinforcing, just with pure concrete blocks. And then we've got what we call in situ concrete, which I'll talk about shortly, which is concrete that is poured on site. In situ's, I think, Latin for on site. You could look that up if you wanted to, but it's what we call on site poured concrete. You're going to be doing on site poured concrete for your abutments. So there's a nice word you can use, in situ poured concrete. There's another thing to think about as well in terms of your notes. How the hell are you going to get a big concrete truck over there? We'll talk about that a bit further down the line. The other type of concrete which I mentioned before is pre-stressed or pre-cast concrete. And that's concrete, these bits of steel in here you can see at the top, stretched through vertically through here. There'll also be some horizontal members as well. They'd be used for things like floor slabs, beams, bridge beams, etc. Wall panels is another example of pre-stressed concrete. Probably one of the fastest ways of construction there is, standing up wall panels and clipping them into place or bolting them into place. Twin T's, double T's. I keep this in my notes because I was involved in a job, Mount Albert Pack and Save, which is just around the corner here from Unitech. The lava flow coming down, oh here's me using geotechnical terms, I shouldn't really be doing that. Okay, the stuff what comes out of volcanoes and flows down the side of the hill, that lava flow went down through past the Pack and Save, and out towards Point Shed. Now, because that's volcanic rock, you can't just get a digger and go and remove it. You've got to actually blow it up in segments and remove it that way. So construction was very, very costly, and a very clever engineer that I was working with came up with the idea of using twin T's, which are this one here, which has got the two members coming down, because with twin T's, the height difference was about 200. So therefore he was able to save 200 in excavation underneath the Pack and Save. There's a large car park under that building. And that solution saved foodstuffs quite a lot of money at the time. That's an example of using twin T's instead of single T's. There was a disadvantage. It's the weirdest thing. Before they loaded it up with all the stock, the building used to bounce. And the guy driving the forklift, when he was loading all the stock up, was literally bouncing. It was like he was on a trampoline until he got weight down on the twin T's. So the twin T's, they didn't realise it at the time, but they ended up with a lot more bounce until the whole place was loaded up. It was weird. I was down in the car park and it was like you could hear this thing bouncing up and down on the top as they were loading it all up. What are they for? They're used predominantly in a beam situation where you're holding a floor, like a floor or ceiling up, okay? And they're concrete in shape. I'm going through the types of concrete, pre-stressed concrete. There's some explanation there on other types of concrete. I haven't asked any questions on that by memory in the test. However, I have asked about steel grades. Most of our steel comes from Waiuku, the steel factory in Waiuku. And there's two types of grades, grade 300 and grade 500. The most common grade, and this is a question, is grade 300 steel. It's also a good note actually, because that's what you'd be using in your job. 500 is a different type of grade, and it's considered not weldable. And I think I'll put that as a question as well, but I just want to talk a little bit more about that. we don't do welding and reinforcing anymore in New Zealand, okay? So if you want to lengthen a bar, you don't just weld the tip, you overlap it. They might do that in other countries to save money, but we don't do that in New Zealand. And I guess, one, we're a Western country, but two, we have a lot of earthquakes and situations.
How much do you overlap it by, sir?
Beg your pardon?
How much do you overlap? Like, is it a big distance or a small margin?
Well, when you've got for example, a building with a slab that's going for a long, long way, and you can only buy, say, 7 metre long reinforcing, and say the building's 30 metres, then you're going to have to overlap one and then overlap another one as well, maybe even a fourth one, right? And that lap binds each section together. And it's the same when you go up. Any building in the city or any multi-storey building, they don't have, like, I don't know, the Burj in Saudi, in Dubai, sorry. That wouldn't be one big long line of reinforcing. As they go up, they overlap the bars all the way up. Yeah.
And then you use the unribbed bars to tie them together?
Yes, in this direction, if it's circular or square.
But if it's two overlapping bars, how do you tie them together? Is it?
Well, generally they tie them together with just thin wire or something like that. Or I've seen these days they use those ties that boy racers would know all about. And they tie on their hub caps when they so they don't fly off.
Or is it
Yeah. But in the old days it was wire. It was pretty much a zip one.
So it doesn't really matter too much?
In terms of no, because once the concrete binds it,
The concrete's strong.
yeah. But with the vertical ones, they don't want them going like this, bending in or bending out, as it's being poured. So they clamp them together with ties. Yeah, the 500 grade is stronger, but it costs more. So the 300 is the most common way to use it. Yeah.
Morning, Pastor. Good morning. Ideal.
When I was talking about round bars, non-deformed bars, the most common name for that is plain bars, by the way. Here's another example, a couple of photos of deformed bars with their ribs on them. And the next thing I want to talk about is welded mesh or welded reinforcing fabric. Now this is something a lot of you may have had some experience with. If you've ever helped your dad do a driveway, or if you've been in a rugby club and they've gone out and done someone's driveway, or even a soccer club or something, or whatever, or just driving along the road or walking along the footpath, and you see this sort of situation where someone's doing a drive. What you've got to realise is that welded mesh or welded reinforcing fabric, as they call it, is not a structural way of reinforcing. It is fine for binding the concrete on a 4-inch or even a 6-inch driveway, and it will work as far as the strength of a truck or something like that goes on it. But they don't use it for walls and floors and walls and ceilings and things in houses, or for structurally binding a house together. What they tend to do with floor slabs on new builds, I'm just trying to remember back to mine, is they tend to also run reinforcing rods through it, and they tie it all onto the mesh. Mesh is basically just a way of stopping the concrete cracking at the end of the day. Formwork and placing concrete. This little diagram that I'm about to do is got a couple of questions in the test on it, and I've had a lot of students that are a bit confused because in other countries they call things slightly different. Okay, I said I'd leave that, so I'll leave that. Does anyone know the difference between form work and false work? Form work and false work. Because I didn't. Straight out of school, had absolutely no idea what my lecturer was talking about. Okay, this is what we call form work. And the way to remember it is that it forms the concrete to the shape you want it to form. This here is what we call false work, which is basically everything that's holding the formwork up in place. Okay? Now I've seen formwork that's been steel, where they've washed it down and moved it along to the next section, then the next section. And on the Clyde Dam they did that a lot as well to save money. Because you can only basically use reinforced tannalised timber so many times, and you've got to buy some more. Whereas with the steel, washing it down, you get a more smoother face, and you can move it along to the next bit. False work. False work does not have to be fully tannalised. The tannalising process is a process where they make the timber more durable to the outside elements. In other words, it can be out in the rain, it can be in areas where there's geothermal reactions, it can be close to salt sea, and all that sort of thing if it's been tannalised. If it hasn't, it doesn't last very long. It's like putting a piece of furniture outside. If I put this bit of furniture here outside for a few days, it's got some sort of covering on it that might keep it for a few days, but underneath it's untannalised. If I turned it upside down, it would rot within just a week probably. So we tend to use untannalised, very cheap timber for this, because what happens, it gets ruined anyway. By the time you get your hammer and you pull it all apart, pull it out, it gets all broken up anyway. So the cheapest chuck away timber, but for this we tend to use tannalised or steel. But the confusion in New Zealand is typical Kiwis. After saying boxing and false work and form work, you're going to get a Kiwi guy going, "Where's all the boxing?" And you guys are going to be going, "Roger never told me what boxing was. I know what form work is." This is what we call boxing. Okay? So when you're calculating on a job the cost of anything, if you're a surveyor and you get sent to a job to measure up or take some marks on some boxing, they're talking about all of that, and you can question the person who says it and say, "Does that mean you want me to take a shot on the top of the formwork?" And, "Oh yeah, that's what I mean." So boxing is everything, all right? Formwork, false work, and there is a question on that in the test, and you may like to read those notes and include something like that in your assignment as well, because the abutment drawings you're doing is